Hello everyone, we are Group 3 and today we are presenting on building the front-end layer, one of the most essential parts of scalable web architecture. Hello, I'm Chandrika today and with me are Sumaira Mohammed Badhun and Nisha Tasmin. Now, into slide 2. This is scalable front-end components. To build a highly scalable front-end, we need to understand all the major components that make up its architecture. On the front-end side, we have DNS, load balancers or reverse proxies, web servers, and horizontal scaling. On the back-end side, components like web services, object caches, and message queues and file servers work together to support the front end. Our focus today will be mainly on the front end infrastructure and how each infrastructure, each component contributes to scalability. Now, in the third slide, what is DNS? Let's start with the domain name system DNS, often called the phone book of the internet. Its job is to translate the human readable domain name into a machine readable IP address. This is called the first point of contact whenever a client tries to reach your website or web service. Without DNS, what will they? Users would have to remember the long strings of numbers instead of a simple name. Then, in the next slide, latency-based routing. A great example of modern DNS service is Amazon Route 53. It uses something called latency-based routing to improve the performance. Here's how it works. When a user tries to access your application, their request goes to Route 53 server located at a nearby edge location. Route 53 measures the network latency to your application's different regions. It then returns the IP address of the region that gives the lowest latency, meaning the fastest response. This is actually smarter than the traditional GeoDNS because it uses real-time network performance rather than just physical distance to decide which data center is best. To take this discussion forward, I will pass it over to Sumaira Mahmoud Badhan, who will dive into the next part, load balancer.
Thank you, Chandrika. Um, Now let's talk about load balancing. DNS round robin load balancing is a simple way to share traffic across multiple servers. The DNS keeps several IP addresses for the same domain. When users send requests, DNS rotates through the first list server 1, then server 2, and so on, and the cycle repeats. This evenly spreads user load without special hardware, but if a server fails, cached DNS record might still send user it. That's the main drawback. Now let's move on to the next slide. Deployment. In a deployment with a load balancer, the process starts by setting up a load balancer to handle incoming traffic. Next, we deploy the application on multiple web servers. Then we configure the load balancer to distribute requests evenly across those servers. Once that's done, we use it as part of our deployment strategy, allowing zero downtime during updates. Finally, we monitor performance and scale up or down based on user traffic. Now let's talk about types of load balancer. There are mainly two types of load balancers, hardware and software load balancer. Hardware load balancers are physical device with very high speed and reliability. So larger enterprise with high traffic load might find hardware load balancer. On the other hand, software load balancers are flexible and can run on regular server or in cloud. So small to medium sized enterprises might find software load balancer. Now let's make it a bit clearer with this image. This figure represents a software-based load balancing setup used in many web services. At the top, the elastic load balancer receives all incoming user requests and distributes them among multiple front-end web servers. These servers handle the user interfaces and then sends requests to an internal load balancer, which further distributes them to the backend web service server for processing. Now let's discuss the hardware load balancer using multiple load balancer. This figure represents a multiple load balancer architecture under a hardware-based load balancer. At the top, A powerful hardware load balancer receives all the incoming traffic and distributes it among several software-based load balancers. Each software load balancer then forwards requests to its own group of web servers for processing. This layered design combines the speed and stability of hardware with the scalability and flexibility of software, ensuring high performance and zero downtime even under heavy traffic. To take this forward, I will pass it to over Nishat Tasnim, who will dive into the next part, web server.
So, what are web servers? Web servers are a kind of connectors. They mitigate what a client wants and what is stored on our databases or browser. So when a user asks for something, some request, then web server is on the rule to deliver it from the main databases to the user. So what we can see here, it handles requests and render UI and communicate with backend services, that is the databases. We may use PHP, Python, Ruby, etc. So these are on a huge task. As for an example, Node.js. This is a server-side JavaScript runtime environment and it's renowned for high throughput. That is, when the user asks for any service, it delivers to that call with efficiency. So these kinds of web servers play a very prominent role in enhancing user experiences. So that is the end of our presentation. Thanks for being with us.